Welcome to Executives at the Edge, the podcast from Amplify. Each episode features insights from the top network, cloud, and technology executives, giving you key takeaways to help you grow your revenue and bring solutions to market faster. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers propelling the AI-powered digital economy forward. Well, I'm really super excited to have Greg Bryan. He is the Senior Manager of Enterprise Research at TeleGeography. And today we're going to cover a really fascinating aspect. Why is the wide area networks, why is bandwidth going through the roof? And Greg has a very, very great insight in his models and an upcoming research report that will talk about what's going on the WAN side. A $500 billion market continuing to grow. So it's going to be very fascinating. AI obviously has a big part of this. So Greg, welcome to Executives at the Edge. And with that, if you can talk a little about yourself and TeleGeography, that would be appreciated.
Yeah, absolutely. Thanks, Pascal. It's great to be on here again. And I should say I've had you on my podcast before. We got to do that again now as well. So it's always good to talk, right? Yeah. But yeah, who I am, I've been an analyst at TeleGeography for 20 years, just about, which is hard to believe, but I'm coming up on that anniversary. I guess I just kind of like it there. We're a data and analytics firm that's totally focused on the global telecom market. A lot of people know us for our maps of submarine cable and internet infrastructure. It's in the name, telegeography, right? One of the things that we're focused on is how location around the world impacts the telecom market in terms of pricing, available infrastructure, latency, all those kinds of things, right? So we're looking at the infrastructure of telecom service, the costs of telecom service, the locations of all of these things, and how they work together.
So Greg, tell us more. I heard you're going to be at our global NAS event in Dallas on November 10th through the 14th. Of
course, yeah.
That is one exciting show. We're going to cover a lot on network as a service and really what's going on with AI and NAS for AI. And so really excited to have you. And that's going to be a really fun event. So for all you listeners, you want to go to Global NAS event, G&E, to attend this event. It's going to be really, really great. So talk about the global WAN market size. You've been doing a lot of analysis on this. I guess you have a report on this. What's going on there?
Yeah, absolutely. So and first I'll say, always a pleasure to get out to G&E. My colleagues and I have been going for years and years, and I think in many ways the mission there at Amplify overlaps well with a lot of the things that we think about, at TeleGeography. So it's great to get to the event and talk to folks working in the industry that have been providing us with data, using our data over all of these years, and really get a finger on the pulse of get me out of my spreadsheets and into what this means, in the real world. So today, as you asked, I'm going to talk a lot about work that I've done in my spreadsheets. But basically, we have created a global WAN market size. And the idea of this, again, sort of going back to a lot of the conversations I hope to have at G&E, is to make sure that as one of the purposes, I think, of getting together for G&E is to facilitate offering enterprise services, connecting enterprises to the network services that they need to drive all these things that everybody wants to talk about these days, AI adoption and that sort of thing, right? It's to help telcos, managed services providers understand what that market looks like spread across the world, because what's going on in the US or Germany or whatever isn't what's going on in Brazil and South Africa and places like that. So we've built this model based on our years and years of data of various sources to help folks understand what the sort of global WAN market opportunity looks like around the world.
So what is that? Because I think you projected quite a large amount. So I talked to a lot of providers worldwide. And it's staggering that their revenues are massive in the transport side.
It is.
Compared to SD-WAN or cybersecurity or cloud. So bottom line, their focus, their bread and butter has been for decades, transport. It still is and growing rapidly. So tell us more about what's going on.
Yeah, that's a great point. That I think often some of the exciting things to talk about are sort of further up the stack, if you will, and new. But the core business of providing network services is really the kind of the foundation of all of this. This is a model that I've created. It has lots and lots of assumptions. Poured over the economic literature to try to figure out how many multinational enterprises there are of a certain size around the world. All of this stuff is hard to nail down. So we ran various versions of the model, right? So our total revenue ranges pretty widely, but the kind of median result we got was, I think, a very big number. You're right, about sort of 500 billion annually. Now, a lot of big estimates about the total global telecom market around like 2 trillion. So I think that makes a fair bit of sense. We had some model runs that were lower than that. But the key to it is that really, I think one thing that it undeniably demonstrates is that enterprise connectivity is still a really core central part of the global telecom business. Why we're here talking, right?
So is that really what we're seeing? All over the world, we're seeing fiber going in everywhere. We're seeing fiber in the streets. Is that, AT&T's putting fiber everywhere? I think Verizon is too. And
Yeah.
everybody's putting fiber. So is it because the market's so massive and their core business has been that for decades and decades that basically, does it become the toll bridge of the future? The more fiber I own, the more spectrum I own, the more toll I own?
Yeah, that's a really interesting way of putting it. I like that. And yeah, I mean, again, in the end, like a lot of what we end up talking about are those things further up the stack, and it's kind of more interesting to think about what does your NAS portal look like and that sort of thing. But yeah, in the end, all of these AI tools that are coming down the pike and all that have to have pipes to send the bits down, right? And you have to have a connection to a data center, and that data center has to be connected to all of the other data centers. So I think there's no doubt, as an analyst, people always ask me to sort of predict the future, right? Predicting the future is hard, and the more certain someone knows the future, the less likely I am to believe them. But I think one fairly certain bet, right, is that there's going to be quite a bit of development, like you say, in fiber markets. And you mentioned AT&T and Verizon, but we're seeing people developing fiber assets all around the world. That's submarine cable builds are ramping way up. Local access builds in all parts of the world are ramping way up. I think there's no doubt that underlay is very much on the minds of the providers, and that's exactly what this product that we've done, this model that we've created, is aimed to look into.
So what's driving? Is it AI is driving all this bandwidth demand? Like, is bandwidth being driven more and more now? And what's causing this? Because for a while it was probably kind of stagnant. The workloads were the same, business workloads. Is it really AI, and is it data center interconnect? There's one predominant use case because more and more data centers everywhere. Everybody wants to be interconnected. AI is living in data centers. So can you tell us a little more?
Yeah, no, that's really interesting. So first I would say that. When we do this thing called the WAN manager survey, where we ask folks who are running large multinational networks kind of what trends they're seeing. So included in that would be like, what underlay services are you running? What bandwidths are you running those services at? Have you adopted SD-WAN? All these kinds of things, just basic metadata about what their networks look like. Then also, of course, a bunch of my colleagues at TeleGeography are looking after the infrastructure side. So how is the supply side, sort of developing? So I think we get to see that a little bit from both sides. But in answer directly to your question, I would say that, starting around the 2020s, obviously COVID pushed a lot of people off their, POTS, right? Or SIP trunking or whatever they had in place, right? Towards video, right? As in UCaaS and all that kind of thing. So I think there was definitely a sort of increase in bandwidth demand just due to that, right? Obviously, compression is better, and these tools work very well on a variety of connections. But enterprises saw a lot of demand from that. And you're right, like previously, business tools, hadn't changed in their bandwidth demand that much, but that was a big booster. And then I think also before you get to AI, you have to include the change to cloud, like you were alluding to, right? That no longer you connecting to an on-prem data center, and especially way back in the day, mainframes and things like this, right? But you've pushed all of this data and your apps and your dev, right, onto the cloud. So the hyperscalers are getting a lot of that, and that's increased bandwidth demand. To your point, yes, there's definitely massive bandwidth demand increases between data centers, and that's where we see the really big numbers that some people talk about, and that's where you are talking in 100 gig and 400 gig kind of waves and whatnot. But even at the individual office level, we're definitely seeing bandwidth demand increases. I think currently we're running our WAN manager survey right now, so I'm curious in a few months when we have that done to see how things have changed since the last time I ran it a couple of years ago. But I think we're probably right on the cusp of where AI is really the driving force for those bandwidth demand increases. They know that is really coming down the pike. It started to happen, but I think the previous increases that we've seen have been due to changes in things like your unified communications, your move to the cloud, and that sort of thing. And we'll just be starting to see the AI-driven bandwidth coming here in the previous 6 months and in the next couple of years.
I also think that, with AI, what I'm seeing is in the carrier Ethernet world, we've already interconnected all the telecom providers at the data plane level at the, EN and Is. So all the providers are interconnected together with their switches or routers already at, was 10 gigabit, now 100 gigabit. So we have a full interconnected global ecosystem at the NNI level, network to network interface between these providers. And it just means that if they turn up VLANs between each other, they can connect private circuits, private circuits meaning connections. But it's shared in the way that it's not, you don't get 100 gigabits if you have a port, you get a port at 100 gigabits, but you're sharing it at the back end as a statistical model. But the good news is I can get to anywhere by stitching together those paths. And with our automation APIs, we can do that very rapidly now. Yeah. So I'm seeing that the 100 gigabit Ethernet is going through the roof. And stay tuned at GNE. We're going to talk a lot about how we see AI and transports come together. And we're seeing same thing for wavelengths. We talked about 100 gig, but 400 gig, 800 gig merging, but they don't have the NNIs in place. So to put all the networks in place, to interconnect them, to get to all the data centers, it's going to take a while. So I think for us, carrier Ethernet is in a very good position now because of this AI drive. Now, what's driving this data center interconnect is these models. You have models that have to be synchronized across the planet. They're bigger models. You got also agents now talking to models and the whole agentic realm coming in. So I think we are in a very good spot. And the layer 3 fabrics are too complicated to connect. And layer 2, I think, is better. And layer 1 gives you more dedicated bandwidth. So I think there are a set of use cases that depends on what the use case is, what level of transport you use, layer 1, layer 2, or layer 3, right? And love to hear your thoughts about how do you see that?
Yeah, no, that's a great question. And I mean, certainly I agree that, first, like I said, the major upticks in bandwidth demand are going to be are currently right between the data centers, like connecting all of these models to each other. You create a model in one place, you have to push it all around the world, I still also see this, bandwidth demand going down to the office level, right? So, and again, it depends on what kind of office you're talking about and that sort of thing. A lot of our customers for our WAN cost benchmark will benchmark enterprise networks to show kind of what the market price for an enterprise network would be, which is one of the sort of key inputs that we have to this market size model. But there in our customers, we still see, Pascal, you'd be really surprised a real wide variety of bandwidths at the office level, right? So a lot of enterprise sites out there still running pretty small connections, right? So and by small, I mean like less than a lot of us have at home, right? 50, 100, 500 kind of meg sort of connections. That's where depending again on what kind of activity is happening in that office, you're going to see some real changes in the coming years. As if you're using a model for inference, obviously the latency is really key there. So what's your data center location, but also how much bandwidth is that going to eat up once things are up and running, or creating the data lakes for training. Again, happening from certain types of offices, but I think certainly in those cases, right, you're as you say, going to see a lot of people sort of moving away from the any-to-any connectivity that enterprise WANs have traditionally been made up to, and towards something like carrier Ethernet. I'll say this, and it's kind of a when you're making a model, there's a lot of things to wrangle and that sort of thing, and we have some limitations there in terms of how much burden I can put on the analysts that I'm having actually do this, right? But our model, we call it a bottom up approach, meaning we're building the market size up from the demand side and the pricing, rather than looking at 10K reports and things and building just a top line kind of number. What that allows us to do, Pascal, is that we can break all of this out by 231 individual countries and several different network underlay products. So we're tracking the revenue size for MPLS, DIA, local access, and SD-WAN. I wanted to include carrier Ethernet, point-to-point Ethernet, right? Which at TeleGeography in our pricing database we call E over MPLS for the most part, right? It was too complicated to break that out geographically because it's not a port-based service, is based on a metro price. We're going to change the model next time we do this and be able to include that. But we also found that at this point in time, right, most enterprises were still on an any-to-any kind of WAN. Believe it or not, a lot of MPLS is still out there, or DIA, obviously, some amount of business broadband. But there are enterprises I've talked to, plenty out there that have moved to something I'll talk about later when we get to different WAN configurations, but what we call the kind of hub and spoke model of direct Ethernet connections between the office and the data center. But most are still on a kind of legacy network, whether that's an MPLS network or some MPLS and hybrid kind of network. So that's where the model was focused, was on still the any-to-any stuff plus the local access. And then the final thing, I know I gave a long answer to your relatively short question there, but the final thing I would say about that is that there's also still very much a limitation on these bandwidths at the last mile, right? So, when you have, like you mentioned, sort of all, this network of NNIs and 100 gig, it's that, that's always all talking about the data center connectivity. If you have to get to the office, then it's down to this, thing that you were bringing up earlier. Has anyone built out fiber to that office? What's the kind of bandwidth we can even get at that office? It's a big world. There's a lot of enterprise sites out there, and a lot of them, have relatively few connectivity options when it comes to the last mile. So I think, again, that's another place where over the rest of this decade, things are really going to develop, both with fiber outlays, with the potential of LEO satellites, for example, and things like that. But right now, there's definitely some limitations, especially globally speaking, in terms of how much bandwidth you can even get to the end customer, right?
Well, interesting, you talk about being at the sites are still wanting lots of bandwidth.
Mm-hmm.
We did a carrier Ethernet over broadband standard because we found that carrier Ethernet
Right.
that was run over OTNs, optical transport networks, or MPLS networks, they were fine. But when you talk about a broadband network, the characteristics are very different on that broadband
Right.
that carrier Ethernet had to run. So it's layer 2 over broadband. So it's layer 2 over layer 3. And that's kind of very traditional how data centers are built now. So when we did that standard, we're seeing now that it's really an important standard for a couple of reasons. Let me talk about number one. We're seeing this, direct-to-device happen now with all the LEO satellites, and there's more and more going up. More and more moving to the idea that broadband's coming from space with low, orbit satellites. So that's really, really great. So then we also have fixed wireless 5G that's available now, which a lot of bandwidth, not a gigabit, but, certainly 100 megabits sometimes, depending on locations. So we're seeing that the broadband loop is getting faster from other mediums than copper and certainly from fiber. It's now adding in wireless spectrums and now satellite spectrums. So we consciously put a standard on layer 2 over layer 3 for that reason. And we're seeing more and more now you can get access to all of these different loop technologies and still have a layer 2 topology. And why is layer 2 important? Because I can now have my IP addresses on a layer 2 fabric and not have to deal with peering and IP addresses and issues, which is a big problem in the address space, especially with the V4. So that was one big thing. So basically, as a provider, I can go to market and buy anybody's local loop broadband and run layer 2 over it and manage it on my IP address space. But the other part I'm seeing now, I think is going to play a very predominant role in this layer 2 or carrier Ethernet over broadband is as models appear everywhere, from smart cities to everything that's going to be driven by AI, it has to connect to all of these peripherals, sensors, cameras, and all of this is being driven by the models have to talk to the peripherals to get input, the senses of what's going on in the real world. So I think massive opportunity ahead. And stay tuned at our global NAS event. We'll talk a lot about how we see, especially carrier Ethernet and AI emerge. And then also what we're doing with automation to turn up these circuits very fast, and how we see a world of AI with, model context protocol, MCP, how that will work with our APIs and so on. So any thoughts? I know you talked about MPLS still very big. Any thoughts about this whole emergence with, AI connecting, all the peripherals, or how there's much more connectivity options now for offices?
Yeah, absolutely. So my first thought to sort of bring it back to the model and mention how all of this breaks out, right? So again, the reason that we do the model the way that we do it is so that we can break it out into fine granularity, right? So there's big data tables of what's the MPLS versus local access versus DIA revenue breakout in a specific country, for example, right? And so that really gives you a feel for how all of this. I was talking local access before in terms of the available bandwidth, but we're looking, of course, at price. We've been collecting prices for these services for sometimes 15 plus years, and the way that it breaks out now. Definitely, enterprises have been leaving behind MPLS, but MPLS is still about a third of global revenue, just because it's pretty expensive, right? And also, the enterprises are fairly slow to change, right? So for a bunch of reasons. One, they have long-term contracts, right? So it's and two, it's hard to rip and replace. Sometimes that requires a lot of upskilling and that sort of thing, right? So if you had asked me 5 years ago, and SD-WAN is new and exciting, and say, MPLS is going to just pretty much disappear. I never would have said disappear, but it's going to diminish a lot by the middle of the decade. And it has gone down. There's no doubt MPLS usage has gone down, but there are particular situations where folks definitely feel like they still need it. About another third, a little bit less, is from internet. So mostly their enterprises are talking about DIA still in places like the US and Canada or Western Europe, where you can get Gig E business broadband for really good prices. That's more common, but in a lot of places in the world, enterprises, even if they're using internet, really need that security of having carrier grade SLAs and whatnot. Then really about a third of global revenue comes from what you're talking about, local access, right? So and opening up those options, I think is going to be huge. So as you mentioned, specifically like LEO, like 5G fixed wireless access, we're definitely seeing an uptick in availability of 5G fixed wireless access, as well as enterprise uptake for it. And for a lot of the things that you're mentioning, so like in this AI ML kind of world, you're having a lot of more devices connected, right? That have big data transfer needs. You're having the ability to spin things up very fast. So when we're at G&E and we're talking about what does NAS mean, right? on-demand connectivity is always going to be limited by the physical availability of a service at that site. Well, fixed wireless access is really one of the most efficient ways to have on-demand kind of connectivity, especially for a location that's not already popped by diverse fiber providers and things like that, right? So I think like in answer to your question, again, no doubt, I think we're going to see some massive changes in that local access market. And certainly, sort of to your point, Ethernet being a central part of that, without a doubt, with layer 2 in general, right? Because of the ease. And again, like I sort of mentioned in terms of thinking through this from the enterprise perspective, Ethernet's pretty easy. Everybody knows it, right? It's they can do that. We need always more sort of plug and play options where they can ramp up connectivity on an ongoing basis. I think that is something I'm going to be really interested in watching over the next several years, Pascal, is just how quickly the network has to react, right? So, we can all feel this in our lives, that one of the things AI is going to do is just speed everything up, right? If you need to do, understand a new sector of the market or something like that, you can now do that with like an LLM much faster than you could before, and that's going to trickle down to everything that we do, networks included, right? Networks are going to have to adapt a lot faster. And I think that network managers are certainly looking for anything, like you mentioned, that facilitates the ease of that, right? So how easily can I get spun up between me and my data center? And there's no doubt that carrier Ethernet is going to play a huge role in that.
Well, Greg, I think we can go on and on. It's been a fascinating episode. Thank you so much for all that insight. And with that, I think we're going to conclude. So I want to thank you again for being on this show.
Yeah, it's my pleasure, Pascal, and I can't wait to catch up at the event.
Thank you for listening to Executives at the Edge, brought to you by Amplify. Be sure to follow, share, and leave a review. Catch every episode on your favorite platform or visit us at amplify.net.